Hey everybody, welcome back to another exciting Algebra 2 class. It's good to see you today. Well, I can't see you, but you can see me, so it's good for you to see me today, is what I should have said. But I can see you in my mind, and I can see everybody watching, and hopefully you're having a good day. What we're going to talk about today here in Algebra 2 is in your book, if you're following along in the book, we are in Chapter 1, Section 2, and that is on page number 9. Today we're going to be talking about adding, subtracting, and multiplication with polynomials. So let's first of all kind of review just real quick about what is a polynomial, because I know it's been a while for some of you trying to remember some of those words and things like that. So a polynomial is a algebraic expression that has more than two, well, really more than one. A polynomial can be two, but usually we'd use polynomial with three or more terms, but two or more terms is the official way to say that. So what does that mean? Well, if you look here at the screen, you'd have something like 5x plus 3. That is technically a polynomial because poly means more than one, so that's more than one. Nomial is a word that we don't use, but we would say more than one term. Okay, more than one term. So this would be another word for this would be binomial because there's two. And if I added another one for y, then that would be a trinomial. And then if I added another one, 6z, then that would be a quadrinomial. No, just a polynomial. Anything more than 3, we don't have a fancy name for it. It's just still a polynomial. So really anything 2 or more. So what is a monomial? Well, a monomial is just one. Okay? And so that's the difference. Monomial, 1. Binomial, 2. Trinomial, 3. Polynomial really is anything 2 or more. But typically we just use polynomial with anything 4 or more. And we'd use bi and trinomial for the ones with 2 and 3. All right, so with that being said, and probably when I mentioned that, you're like, oh, yeah, I remember that from algebra class. All right, good. So what we're going to do today is we're going to first of all talk about addition and subtraction of polynomials. This is combining like terms, and if you've been in my class in Algebra 1, I give the illustration of going to a supermarket, and you go in there and you have to put all of your vegetables or all of your fruits in separate bags, because when you take them to the checkout counter, they have to have them separated because they weigh them. So you can't put oranges and apples together. And so that's the same thing that happens when we're adding and subtracting polynomials. We can't add apples and oranges, so they have to be exactly the same. Let's put one up here and let's talk about this. Let's do minus 3x squared minus 6x plus 8 plus. So that's our first polynomial. It's a trinomial. So that's our first polynomial. Plus, we'll put another trinomial on here. 8x squared plus 7x minus 14. Okay? So what we want to do is we want to add that or combine that. Now, in our principles that we already went through, remember in addition and subtraction we can group or ungroup these, and we talked about that being the associative principle. And so we can take and we can put these groupings together and we can take away groupings. So what we want to do here is really we're just going to take away these parentheses because they don't really mean anything, because all it means is that those are grouped together. But we learned the associative principle, which means we can we're just going to group the whole thing together. We're just changing the grouping. And so here's what this is going to look like. This is going to look like minus 3x squared minus 6x plus 8, don't forget this plus sign, plus 8x squared plus 7x minus 14. And so now we just have like this big, long addition and subtraction problem in there. So now this is where I say this is like going to the supermarket. So we are looking for all of the apples, we'll call the X squared term, the apples. So there's some x squareds, and right over here some more x squareds. Notice I also included the sign with that. That's important because they are positive 8x squareds, not negative. This is negative 3x squareds. And so now when we combine those, if I had negative 3x squared and I add 8x squared, what do I have? That's right, I have 5x squared. Technically a positive, and it's a good thing to write that sign there. It's not a bad thing. So write that sign there. That'll help you to differentiate with your signs. It's really good to use. And so now we'll go to, those were the apples, so let's go to the oranges. So the x terms, those are the oranges. And if I have negative 7, or excuse me, negative 6 oranges, or x's, and I have a positive 7 oranges, and I combine those together, I am going to end up with a positive 1 orange. I end up with 1 orange. If I was negative 6, but I got 7, I now have positive 1. And then we'll go to the next one, and that is these will be the bananas, I guess. All right, so we have 8 bananas minus 14 bananas. So we're going to end up coming out with negative bananas because we didn't have enough. 8 minus 14 is going to give us minus 6 bananas, minus 6 bananas. So this is our answer, but let's modify this just a little bit to make it look more algebra-ish, all right? We don't need this positive. Why not? Because it's out front and it's a positive, so it's understood. So we don't need that. So we can get rid of that, so we can put 5x squared. We also don't need that 1. Why not? Because it's a coefficient of 1. We never have to write that. And so we plus x minus 6. And there you go. That is good algebra right there. That's the best way to write that. If you write it the other way, plus 5x squared plus 1x minus 6, it's not wrong. It's just this is a little bit better format to write it in. And notice that I always want to start with the way that you do these is alphabetically and then in descending order of exponents. So I'm always going to start with the biggest exponent. I'm always going to start with A, B, C, D, E, F, G. So alphabetical and then descending exponent. So 2, and this is an exponent of 1, and this would be, technically this is an exponent of 0. Now that's like mind blown, I know. But remember, anything to the 0, we learned this with the exponent rule. Anything to the 0 equals 1. 1, and then we learned in the identity rule that anything with the identity of 1 times it is going to equal itself. So 6 times 1 is just going to equal 6. We're back to where we started from. So, and I'm telling you that because the next lesson that's coming up is division, and you're going to find in division that is pretty important right there. That what I just gave you is going to be pretty important. You need to understand that is the x to the 0 term. But that is an x term, but it's x to the 0. It could be a y term, it could be anything, but it's always 1. Now, that's, again, in this lesson, that's not a big deal. But I'm just kind of prepping you for the division lesson, which is coming up. All right, so now the only trick here is if we have a subtraction sign in there, is that we have to distribute the subtraction sign. So x squared plus x minus 5, that's our first polynomial, minus 3x squared, this is our second polynomial, plus 7x minus 14. The only trick with this, because notice, now I have a subtraction sign. On the other one that we just did, I had an addition sign right there, okay? So a little bit different. Now we're subtracting polynomials. Well, here's the only difference. The only difference is we have to remember to use the distributive property, okay? So we're just going to take that negative sign, and we're just going to put it through there. So let's rewrite it. So we're just going to rewrite that when nothing changes with the first one. X squared plus x minus 5. Now we distribute our negative sign. Minus 3x squared minus 7x. And when we distribute there, that becomes a positive 14. Because remember, negative times negative equals positive. So basically, if you look at it this way, In the second one, all the signs change, because that was positive, now it's negative. That was positive, now it's negative. That was negative, now it's positive. Okay? And now we would solve that the same way. We would just kind of go through that guy and solve for it. So we'd put our x squareds together, and we would get minus 2x squared. Now that is important, that sign out front, because it's a negative. If it was a positive, we wouldn't need to write it. We have a positive x and a negative 7x. That's going to be a negative 6x. And then we have a negative 5 and a positive 14, and that is a positive 9. And so that would be our answer for that one right there. Okay? You can go back and rewind that if you just don't forget to distribute. Don't forget to distribute. The next little section here, I think, again, I just used the word distribute. This is a basic algebra term. You should know this. But really the next lesson, the next part to this lesson on page 10 is distributing. So now we're going to multiply a monomial times a polynomial. And the way that we do that is we just distribute it to each one. Okay? And so, again, I'm kind of going through this fast because you should know how to do this already. If you don't, you can always scroll back and watch it again and watch it several times if you need to. So we're going to distribute here. Negative 3 times 5 is negative 15. X squared times x squared is x to the 4th. And then we would go here. Negative 3 times negative 8 is going to be a positive 24. 24, sorry. And that's going to be an x cubed. And then we're going to distribute here negative 3 x squared. And that would be our answer right there. Okay? All right. So that's multiplication using distributing. The next thing that we do here in the lesson is we use FOIL. And so we're going to go ahead and FOIL this. And if you remember, FOIL stands for F-O-I-L, first, outer, inner, and then last. First, outer, inner, last. And that helps you remember how to do the foiling. So here's what this looks like. I have 3x plus 4y. That's my first binomial. And foiling works when you have binomials times binomials. It doesn't work with monomials like distributing does. All right, so what I'm going to do here is I'm just going to do the first, and so that looks like this right here. Those are the first. That's the first one, and that's the first one. That's what that means by first. So I'm going to get 6x squared. And then I'm going to do the outers. So I'm going to get a positive 3xy. I'm going to do the inners. I'm going to get a positive 8xy. And then I'm going to do the, sorry about that, I'm going to do the lasts. And I'm going to get a positive 4y squared. Positive 4y squared. All right, so I'm almost done. The last step to foiling is always combining the like terms. You'll see these two middle terms are going to be like terms. So again, that goes back to the whole idea, the concept of you're putting the apples in one bag, the oranges in another bag. So I'm going to get 6x squared plus 11xy plus 4y squared. And that would be my answer right there. Okay, circle that. All right, I know this video is going to be a little bit longer than some of my other ones. There's just a lot of information here, but I want to make sure that I'm doing an example of all of these so that you can see what's going on. All right, the last thing is when you have something that looks like, well, there's actually two more things, but when you have something that looks like this, a trinomial times a trinomial, x squared plus 7x minus 2. You're not going to see this a whole lot, but you do see it occasionally. X squared minus 4x plus 3. Now, there's really two different ways to do this. You could stack it up, like basically put them on top of each other like this, and you could multiply this way. I don't really love that method, but if you know that method, or if you want to look at the book and try to understand that method, you can. I like this method, and here's the way I do it. I take the first one, and I distribute the first one. Okay, so what do I come up with? X squared times x squared is x to the fourth. X squared times minus 4x is minus 4x cubed. And then x squared times 3 is 3x squared. Okay, so let me erase that. And then I would come up and do the next one. 7x into that gives me plus 7x cubed. There. I get 28. Yeah, negative 28. There we go. Knew something didn't seem right there. Negative 28x squared. And then the last one, I'm going to get the 21 positive 21x. Okay. And then I'll erase those. And then we're going to do this last one. And this is a negative 2 that goes into all these. So I'm going to get negative 2x squared, positive 8x, and I think I can squeeze this in, minus, no, I didn't want to do it, minus 6. There we go, I got it. Now, we have all that all done right there, and now what we need to go do is go back, and we need to combine all those like terms, okay? And so we're just going to go back through it. Let me pick a different color here, and I'm going to find all the 4x, the x to the fourth terms. I just have one, just that one, x to the fourth. There's no more. Then I'm going to find all of the x cubed terms. I have some more of those. So I have those two. So I have negative 4 plus 7, and that's going to give me a positive 3 x cubed. And then I'm going to find all the x squared terms. So there's an x squared, there's an x squared, there's an x squared. And so now I'm going to get 3 minus 28, so that's minus 25, minus 2, minus 27. Minus 27x squared. Let's see, find another color here. And then I'm going to see the x terms, and I'm going to get 29x. And then my last one down here at the end was that minus 6. And so that is my answer right there. I just take them all, distribute them all, and then combine all the like terms. There are some, that the book shows you now, some what they call special products. Special products. And here's what that means. There's something called a conjugate. A conjugate is something like x minus 3, x plus 3. You notice what's the same there? Yes, the x is the same, and the 3 is the same. What's different? That's right, the sign is different. So one's a positive, one's a negative. Well, every time you do these, if I FOIL these, I'm going to basically, the middle term is going to cancel. So if you look at this, outer, first, x squared. Outer, positive 3x. Inner, negative 3x. And then last, negative 9. So look what happens to these middle terms. Positive 3x, negative 3x. Those cancel. And so I'm left with x squared minus 9. Okay? So let me show you a faster way that we can do that. We don't even have to do it all. If you recognize, hey, that's a conjugate. Look, they're the same except for the signs are different. Here's what you do. You do the first and the last. That's all you have to do. You don't have to do the outers and the inners. You save yourself some time because those guys are going to cancel every single time. Okay, and so you just have to do the x squared, and then the last is your minus 9. And so that's a little shortcut there. I like shortcuts. They help make it just, they'll speed you up on a quiz or a test, and they help you out too. They help your brain too develop different ways to find that you can do it a little quicker. And so that's conjugates. Let's see. Oh, squaring. This is the last thing that I think I have for you today, is squaring binomials. So if I have x minus 3 squared, well, what does that mean? Well, here's what it means. It means x minus 3 times x minus 3. That's what that means. Anytime you square something, it's times itself. Okay? Well, let me show you kind of, I don't know, I guess a little bit of a fast way that you can do that. And sure, you can FOIL it, so we can get x squared. That's the first. Well, let me change the color so you can see that a little bit better. So this is the first, and so I get x squared. The outers, I'm going to get minus 3x. The inners, I'm also going to get minus 3x. And that's where the trick is right there, okay? And then the outers, I'm going to get positive 9. Negative, negative. Negative times negative equals positive. All right, so look what happened there in the middle. X squared, we got the same thing in the middle, so minus 6x plus 9. When you're squaring something, here's what you do. All you had to do for the middle terms is add them together, 3 plus 3. And you just keep the sign. 3 plus 3 is 6, 6x, and you just move on. Now, you can FOIL it, and you'll get the same thing, but if you learn those little shortcuts, that will help to save you just a little bit of time. And later, when we're doing things like completing the square, when we're factoring and doing some other things, you'll see that it's going to help you to be able to do some of these shortcuts. Let's see. If you do a cubed, it's the same thing, only you do another time, times x cubed. And so what would you do now? Because now you have that. That's the squared. And so now I have this times this. Well, the way that you would do that is now you just distribute. Okay? And so you can only do FOIL on binomials. You can't do FOIL on trinomials. The way that you solve a trinomial or a polynomial is you FOIL it through. Or excuse me, you distribute it through. You can't FOIL, sorry. And so you're going to distribute the x through, and then you're going to distribute the 3 through. And that's how you would do, you kind of combine those two things that we already did if you want to do a cubed. All right. Well, that is it. That's all I have for you today. I know it was a little bit longer lesson, so thank you for paying attention and hanging with me to the end. See you later.